Let's take a look at command line basics, pwd. pwd is one of the simple commands that you need to learn. pwd stands for print working directory. This command gives us the location where we're currently located in the directory structure. Let's take a look at the manual page. pwd prints the name of the current working directory. There are a couple of options which you usually won't need to use. When we run pwd currently, we see that I'm in my home directory. We can explore other places in the file system and use pwd to identify where we are. Let's use the cd command to go somewhere else. Let's try a few more. You'll see that wherever I go, I can use pwd to find out the location where I am. Using exit to end a terminal session. When you are done at the command line, it is good practice to explicitly terminate your bash terminal session. This is done using the command exit. After you execute this command, your bash session ends. If you were connected to a remote server via SSH, as I was here, executing the exit command also terminates your SSH session. mkdir is used to create directories. After using mkdir to create a directory, we can use the ls command to verify that that directory was successfully created. Let's try again. This time, let's ask mkdir to be verbose. By calling mkdir with the -v flag, mkdir prints a message for each created directory. We can, of course, still use ls to verify that the directory was created. mkdir can also be used to create multiple directories at one time. If you attempt to create a directory and a directory with that name already exists, mkdir will produce an error message. In the previous examples, we created directories directly within the current working directory. It is also possible to use mkdir to create directories elsewhere. This command creates a subdirectory called edu inside the src directory. This behavior can be extremely useful. However, be advised that if the parent directory does not exist, mkdir will produce an error message and will fail to create the subdirectory. This command failed because the examples directory doesn't exist. There's a solution. Let's take a look at the manual for mkdir to find it. The -p flag instructs mkdir to make parent directories as needed. The -p flag can also be used so that mkdir doesn't complain if the directory already exists. Recall that we already created a directory called bin. As we saw earlier, if we try to create a directory that already exists, mkdir will normally fail. But by calling mkdir with the -p flag, mkdir will silently succeed. In all of the examples so far, we've asked mkdir to create directories within the current working directory. We can alternatively call mkdir using absolute paths. Mkdir is an essential Linux command that you will use frequently. You should practice using it to create directories in your current working directory and elsewhere. While you may never use the -z or -m flags, you should learn to use the -p flag. Using ls to list the contents of the current working directory. ls is one of the most commonly used commands. Let's take a look. If I run ls with no arguments, it will display the contents of the current working directory. We can now see that this directory contains 5 other directories: baz, foo, homework, knlm, and zork. Let's navigate to another directory. And use ls to view its contents. We can now see that the current working directory, knlm, contains a number of files and directories. Now, let's use cd to change to a different directory. Now, if I run ls with no parameters, it's going to print the contents of the current working directory, which is /user. In conclusion, invoking ls with no parameters will display the contents of the current working directory. If I run ls with no arguments, it will display the contents of the current working directory. ls also accepts an argument. When I provide an argument to ls, it will list the contents of that directory rather than the current directory. So, here we see that there are a number of files and directories within the knlm directory. If we want to see the contents of one of these subdirectories, one approach would be to use cd to navigate to that subdirectory and then use ls to view its contents. However, there is a faster way. Let's go back to the home directory and try the faster way. Rather than calling cd and then calling ls, we can directly call ls, providing the directory as an argument. In the above invocation of ls, we provided a relative path, knlm/include, as an argument to ls. After doing so, ls listed the contents of the specified directory. We can also call ls using other relative paths, including those that make use of dot and dot dot. Recall that dot dot refers to the parent of the current working directory. In this case, the parent of the current working directory is kenlm. Let's try another. In this case, dot dot refers to the parent of the current working directory, kenlm. And dot dot slash util refers to the util directory that is within the kenlm directory. Using cd to navigate to a directory using a relative path. Let's take a look at where we are, the current working directory. Now, let's use ls to view the contents of the current working directory. We can use the bash built-in command cd to change directories. To use cd, we provide the name of the directory into which we wish to navigate. Let's use pwd to verify that we have changed directories. Notice that in the above invocation of cd, we only specified the name, baz. We did not type /home/lane_s/baz. This style of referring to a directory by only part of its name shows the use of cd using a relative path. The absolute path in this case would be /home/lane_s/baz. The relative path that we used was simply baz. Because we were located in the directory /home/lane_s at the time we invoked cd, the part of the path corresponding to the current directory can be omitted through the use of a relative path. There are two special relative path components, dot and dot dot. Dot refers to the current working directory. Dot dot refers to the parent of the current working directory. Let's recall where we are. The current working directory, baz, is located within the directory lane_s. We could refer to the parent by its absolute path, /home/lane_s, or we could refer to it as dot dot. Let's use cd and dot dot to navigate to the parent of the current working directory. Let's practice some more. What just happened? We told CD to navigate to dot. Dot is another name for the current working directory. Consequently, we stayed in the same current working directory. In other words, we didn't go anywhere. What just happened? We were in /home/lanes/foo. We used dot dot twice. From /home/lanes/foo. Dot dot would refer to the parent directory, /home/lanes. But we used the relative path dot dot slash dot dot. If dot dot is the parent, then dot dot slash dot dot is the parent of the parent. In this case, the parent is /home/lanes, and its parent is /home. So, invoking cd dot dot slash dot dot from home lanes foo takes us to home. Notice what we just did. We used a relative path, lanes/kenlm, to navigate from /home to /home/lanes/kenlm. We could have called cd twice, but this way was faster. Let's go back and see the slower way. We used cd here to navigate one directory at a time. Just as we can use ls to look into subdirectories, we can also use cd to navigate directly into subdirectories. Let's take a look at command line concepts. Understanding complex relative paths using dot and dot dot. Now, let's take a look at one example of a relative path that uses both dot and dot dot multiple times. Now let's go back and take a closer look at this complex relative path. We'll begin by visualizing the directory tree in which we're operating. The directory tree looks like this. For convenience in keeping track of subdirectories, I have color-coded the subdirectories we'll be discussing. The current working directory is /home, /lanes, /kenlm, /util, /stream. Notice that I've color-coded the names in this path to match the corresponding subdirectories in the directory tree. Now let's look at our complex relative path. Again, notice that I've color-coded the names in this relative path to match the corresponding subdirectories in the directory tree. Dot dot, which you see here in red, refers to the parent of the current working directory. In our case, the parent is the util directory, which is also drawn in red here in the tree. Double conversion is a subdirectory of util. Thus, given that stream is the current working directory, dot dot slash double conversion refers to the subdirectory colored in gold in the tree. /home, /lanes, /kenlm, /util, /double conversion. Dot is another name for the current directory. This means that dot dot slash double conversion slash dot means exactly the same thing as dot dot slash double conversion. The parent of double conversion is util. Thus, dot dot slash double conversion slash dot slash dot dot refers to the red node in the tree, whose absolute path is /home, /lanes, /kenlm, /util. The parent of util is kenlm. So, dot dot slash double conversion slash dot slash dot dot slash dot dot refers to /home, /lanes, /kenlm, which we see colored orange in the tree. LM which you see in blue, is a subdirectory of kenlm. So, // conversion // // refers to /home /lanes /kenlm /lm. And because dot, which we see here in blue, refers to the current directory, // conversion // /lm refers also to lm. Wrappers is a subdirectory of lm. So, // conversion // /lm /wrappers refers to /home /lanes /kenlm /lm /wrappers. Which we see here in blue, refers to the parent of the current working directory. So this path refers to lm. And finally, builder is a subdirectory of lm. And so, // conversion // // lm /wrappers /builder refers to home lane s kenlm lm builder. Using mv to move files. The mv command can be used to move files. mv takes two mandatory arguments. When moving a single file, the first argument is the path to the file you want to move. The second argument is the path where you want the file moved to. In the above invocation of mv, I moved the license file from the kenlm directory. The result is a file in my current working directory called abc. Another way to invoke mv is by giving mv a destination directory. For example, let's say we wanted to move the file abc from the current directory into the directory baz. To do so, we call mv, using abc as the source file and baz as the destination directory. As you can see, after the above invocation of mv, the baz directory now contains abc. Usually, it is not necessary to supply any options to mv. However, if you want confirmation of what mv is doing, invoking mv with the -v flag will explain what is being done. By calling mv with the -v flag, mv confirms that it moved the file baz/abc to kennelm/license. mv can also be used to move multiple files to a common destination directory. Let's use touch to create several empty files. Now, let's use mv to move all 4 of these files into the foo directory. The ... notation here indicates that mv allows us to specify multiple source files. As you can see, all 4 files have been moved to the foo directory, using cp to copy a single file. The cp command can be used to copy files. cp takes 2 mandatory arguments. When copying a single file, the first argument is the path to the file you want to copy. The second argument is the path where you want the file copied to. In the above invocation of cp, I copied the license file from the kennelm directory. The resulting copy is a file in my current working directory called abc. ABC is a copy of license. We can use the diff command to verify that the two files are identical. Another way to invoke CP is by giving CP a destination directory. For example, let's say we wanted to copy the file ABC into the directory baz. To do so, we can call CP using ABC as the source file and baz as the destination directory. As you can see, after the above invocation of CP, the baz directory now contains a copy of ABC.